So this is a statement which states that if we have n geometric means inserted between two numbers, then the product of those n geometric means will be equals to the nth power of the single geometric mean between the two quantities. So let's try to prove this statement. So let's say let g1, g2 all the way up to gn be n geometric mean introduced between two numbers. Let's call them a and b. That means a, the first term, followed by the second term, which is g1, then we have g2, then we have gn and b. These numbers are in geometric progression. We have already defined the common ratio. If r is the common ratio, that will be defined as the last term b divided by the first term a raised to the power of 1 over n plus 1. So this is the common ratio. So that means g1, which is simply the first term multiplied to the common ratio. So that means we have a times b over a raised to the power of 1 over n plus 1. Then we can also define the second geometric mean g2, which will be a times r squared. This is going to give us a value a times b over a raised to the power of 2 over n plus 1. So likewise, we can define all the geometric means. So let's define the nth geometric mean, which will be a times r raised to the power of n, or simply a times b over a raised to the power of n divided by n plus 1. Now we take the product of all geometric means, so g1 times g2 times g3 all the way up to gn. So this will be equals to, we have a times b over a raised to the power of 1 over n plus 1. So this is the first geometric mean multiplied to the second geometric mean, which is a times b over a raised to the power of 2 divided by n plus 1, goes all the way up to the nth geometric mean, which is a times b over a whole raised to the power of n divided by n plus 1. Now we have a multiplied to itself n number of times, so we have a raised to the power of n, and we will multiply all the terms contain all the values having b over a. So we get b over a raised to the power of 1 over n plus 1. So we'll be adding the powers, plus 2 over n plus 1, plus all the way up to the last term, which is n over n plus 1. Now we'll need to find out the sum of 1 over n plus 1 plus 2 over n plus 1. Then we have 3 over n plus 1. This goes all the way up to the last term, which is n over n plus 1. Now this is clearly an arithmetic series. That depends the first term, this is our first term, and the common difference d, that will be equals to 2 over n plus 1. So we're subtracting the first term 1 over n plus 1 from the second term 2 over n plus 1, and our common difference is going to be 1 over n plus 1. So now that we have the first term and the common difference, so the sum to n terms, which is given by n over 2 raised to the power of the first term plus the last term. So here we have n number of terms, so that will be n over 2 multiplied to 1 over n plus 1 plus the last term, which is n over n plus 1. So this means we have simply n over 2. So we can replace this value here. So we're going to get a raised to the power of n multiplied by b over a whole raised to the power of this entire sum as n over 2, which is going to give us a raised to the power of n times b raised to the power of n over 2 divided by a raised to the power of n over 2. So we can combine the two a's, so it's going to give us a raised to the power of n over 2 times b raised to the power of n over 2, which is also ab raised to the power of n over 2. So we have obtained, so let's write it down. So we have the product g1 times g2 all the way up to gn. So we have obtained that this product, that's equals to ab whole raised to the power of half whole raised to the power of n. Now ab whole raised to the power of half, what is that? Let us introduce a single geometric mean g between the numbers a and b. So g over a must be equals to b over g, which you can say that g squared will be equals to ab, or g is equals to ab raised to the power of half. That means in place of ab raised to the power of half, we can replace this with a single g. So we have g raised to the power of n. So this is what the proof meant. So that means if we have n geometric mean inserted between two numbers a and b, then the product of all the geometric mean between them, this simply equals to one master geometric mean between a and b raised to the power of n.